In this video, I try to demonstrate how do I use R, a statistical software, to compute the ANOVA analysis to investigate whether the good performing students has a higher motivation score than other students. On the left, we could see a table containing their homework the change in their homework score. We could see the first 5, they improved it by more than 10%, so we say they are good performing students. Some students, based on different reasons, the homework score declined it for more than 10%. We group them as a poor performing students, and the rest are fair performing students. By basic statistic, we could take the motivation score and take an average, and we could see by simple average, the good performing students has an average motivation score of 126. Fair performing student has a motivation score on average 87, and poor performing student 81. So it is very naturally we could see the good performing students has a higher motivation score than the other two groups. But if we want to see how strong the difference is, how could we say that is statistically significant difference, we apply the ANOVA analysis. So firstly, we need to copy this table into an Excel file, and now we could save it as a CSV file. So here we save it as a CSV. We remember the file name. I save it on the desktop. Then now we could go to the R software. There are a lot of there are many tutorials on how do we install the R software, so I do not include that. But firstly, we need to set our working section on the desktop or any folder that you put your file in. So I would change the working section on the desktop, or by command we could use this command, right? So your own folder, because our data is put in a CSV file, and we need to have a name, we have a folder to save it. Say this is a name that we could define, and we will bring the CSV file by a read.csv function, and our file name is book1.csv. So this is the command. This file name is any name that we define, it doesn't matter. The function is read.csv, and book1.csv is the Excel file that we save. So we run this command. To see if we run this command successfully, we could take a look on this file. So we see the first few rows of file. Alright, so I do not need this x and x1, x2. I only need the first 3 columns. Actually, the second column and the third column. The group is here, the motivation score is here. And next we will do our ANOVA, and again a self-defined name, because I want to see if there are any significant difference between good performing, fair performing, and poor performing students. I make the name different. The difference is an ANOVA analysis. So AOV is the function. DIFF is a self-defined name. And in our ANOVA, I want to see the difference between the motivation score followed with the different groups. Keep a note that if it is capitalized, you need to, it is case sensitive. And then this motivation score and group are from the file, from the data frame file. And I run this code. And at last, we see the summary of this DIFF. And we are interested in this value. Based on the 95% confidence interval, if this value is smaller than 0.05 or 5%, then in 95% confidence interval, we say the three groups have different average, and from the basic statistic we have done here, we could see the good performing students are significantly higher than the other two groups. So that is our first finding, no, the second finding of this action research project.